My name is Michael Yang. I'm the Senior Product Manager in Enrisu in Morgan Hill. And today I'm going to show you how to do triple offset short calibration method. And I'm going to give you 3 examples. One is optimum offset lenses. The other one is if you choose the wrong offset lenses, what to expect. And third one is you can design your own cal kit, such as satisfy the boundary condition of the equations. So this one I will show you, this is our VNA MS46522-B extension, the module with the E-band WR-12. So over here I'm going to show you how to do the triple offset shorts, one port measurements using waveguide cal kits, and then here it's good exercise. I always put the extension over here to connect from module to where the reference plane is going to be. Okay, so I have 3 different offset lengths. The first one is as I mentioned before, the optimum length, which is 2.0, and then this is 2.8 millimeter, and this is 3.6 millimeter. Okay, so I'm gonna do the short first. So always good to line up with this line pin over here, and make sure you line them properly. Okay, and then you put the shorts over here. Okay, and it's always good exercise to tighten up. The way I tighten up is using is a clip. Okay, so I make sure I tighten it nicely over here. It's a little bit difficult to do, but it's always good exercise to tighten this thing so that there's no leakage. Okay, so once you've done that, and then you go to frequency over here. Basically, it's from 55 gigahertz to 92 gigahertz, and the number of points I put of 1601. Okay, and then once said that, I go to calibration, and the calibration I select menu cal, which is 1 port cal, and then modify. This is going to be triple offset shorts and waveguide, and I did the cal parameter. WR-12 is already there, and I only do the test port 1 calibration. If you look at the waveguide information over here, it's exactly 2 millimeter, 2.8 millimeter, 2.6 millimeter for 3 different offset lengths. Okay, so I'm doing port 1 reflection devices. So right now this is offset short 1, so I click first one. Okay, and then I unclip this. So I put the second one. So over here, there's a pin to line up. So make sure you line up properly. And then you put the shorts over here, and then make sure you tighten up. So this is the second short. Okay, and then you do the third one, which is 3.6 millimeter. Okay, and to search offset shorts, and click OK, and click done. So over here it says COR, that means it's been calibrated correctly. Okay, and then if you look at this one, so you see this very nicely around the peripheral of Smith chart. So that means it's a good calibration. Okay, and then if you look at the log mag over here display, let's see. So it's pretty line, straight line. I put a scale, so make sure it's 1 dB. Yeah, it's pretty nice and clean, right? So that's pretty good calibration for short for 3.6 millimeter shorts. Let's look at the other two. tighten up. It's very important. You see, it's pretty clean. And then you look at the Smith charts. Yeah, it's always on the peripheral of the ring, so that means it's good calibration. Let's look at the 2 millimeter. Tighten up. Okay, see, it's nicely peripheral, and you look at the log mag. Yeah, it's pretty neat. It's not too bad. Okay, so that means it's all pretty good offsets. Okay, all right. Okay, next one I'm going to show you is the wrong offset lenses. So I select like 2 millimeter, 2.8 millimeter, and the short, so it's 0 millimeter, line 1 0. Okay, I'm going to show you what to expect from the calibration triple offset. Okay, so okay, over here I select menu cal, I select port 1 port calibration. And then over here, I go to triple offset, waveguide, and edit. So over here, since this user defined, so I'm going to select the user defined cal kit and look at here. And I already have it defined over here before, so 0 to 2.8 millimeter. Okay, so let's do that. Let's do the calibration. Okay, only do port 1. Okay, and then go back and do port 1 calibration. So over here, I'm going to put the short line 1 since it's flashy short. So I just put the short over here. And make sure I tighten them up. Okay, so over here, I go to Smith charts. Okay, and then I do calibration. Manual cal, 1 pro cal, reflection. So short one is flash shorts. Okay, and then into 2 millimeter. So here, so put 2 millimeter offsets. Using clip to tighten up. Okay, and then I do the offset shorts, line 2. Okay, and then I go to line 3, which is 2.8 millimeter. And then to line 3. Okay, it's all done. I click done. Okay, so if you look at here, you see over here, this looks abnormal, right? So that means it's not very good cal. And then if you look at the log mag, you see over here, if I go scale to 1, you see over here, this is called singularity. So that's something is not correct. So this just tell you this is bad cal kit. Okay, so in case you need to create your own cal kit, or you have a certain offset lens available, and you want to make sure this whether it's a good triple offset cal kit. So over here, I select 3 different offsets. One is 2 millimeter, and this one is 2.65 millimeter, and 3.6 millimeter. So let's see how good this cal kit are. Okay, so I put the first one, 2 millimeter. clamp on. Okay. Okay, this is the your own design cal kit. So go to menu cal over here, and then one port calibration. So modify, so trip offset, waveguide, and over here you have your own design, user defined. So over here I enter already 2 millimeter for line 1, offset line 1, and 2.65 for offset line 2, and 3.6 millimeter for offset line 3. Okay, so and then click OK, and you go back and do so make sure it's one port calibration, test one port 1, so over here, and then you go back and do port 1. So this is short 1 offset, so I click short 1. Okay, and then do a short 2. Short 2 is a 2.65 millimeter. Okay, short 2. And then the last one would be short 3, which is 3.6 millimeter. Okay, click them tight. It's kind of very thick, so it's difficult to line them up on this one. Okay, and then you click on short 3 and click OK, click done. So you can see it's very nice, and make a scale to 1 dB. You can see better. You see, nice and clean. And let's look at the Smith charts. It should be all around the parameters. You see, very nice. Let's put the short 2. Okay, you can see nice around the peripheral, and then parameters, and then if you look at the log mag, should be clean. You see, very clean and a straight line. There's no singularity, not like the one before the spike. Okay, let's look at the short 1. Same thing, short 1 is a nice and clean straight line. And let's look at the Smith chart. It should be a circle around the parameters. So on this experiment, I have shown you 3 different calibration, trip offset calibration. The first one is the optimum solution, which you pick at 120 degree for electric length of A, and then you can come out optimum length for line 1, for line 2, and for line 3. And the second example I've shown you is if you pick the wrong offset, and then you can see where the defects are by looking Smith chart. It's going to be off the charts, or by looking at the log mag on S11 plot, you can see a singularity, which means a spike on certain offset cal kits. The third one, if you need to design your own cal kit, then you just look at pick three different offsets and look at the equation. If it satisfies all the boundary conditions, then you know you are in good hand. So that's how I show you on the third experiment. You have your own design calculate, and then you don't see any spikes on log-mag plots, and also the Smith chart is all around the parameters of the Smith chart curve. So that concluded my experiments of this triple offset Kits method. If you need any further information, you can contact me directly. My email is michal.yang@enrisu.com. Thank you.